Hello Year 11 and welcome to your next geography lesson. In this lesson we are carrying on with our next topic, natural hazards. Now just to recap, this is the final topic that we need to do, and in this lesson we're focusing on the second part of the topic, the distribution of volcanoes and earthquakes. So when we go through this video, I go through task by task. So you might want to listen to task 1, then download the PDF or the Word document and complete task 1, then watch the video for task 2, and then carry on until you have finished the video and finish all of the tasks. So you might not want to watch all the video at once, but keep pausing it and coming back to it as you go through the tasks step by step. So, in today's lesson, we are looking at the global distribution of earthquakes and volcanoes. We're going to be using our writing frame T, trend, evidence, anomaly. We're going to be describing and comparing the different layers of Earth. And then in the next lesson, we're going to be explaining the theories for changes in the Earth's crust and why the Earth is moving, which then takes us on to look at why earthquakes and volcanoes occur. So, Task 1. You will notice on your work for today's lesson, the first activity is to look at the structure of the Earth. So you need to make sure that you have drawn a diagram like the one on the right. So you will see that there are 4 different layers to Earth. There is the inner core, which is in the centre of the Earth. There is then the outer core. Then the mantle, which is that viscousy layer. And then we have the thinnest layer, which is the crust. Okay, so once you have drawn and labelled your diagram, we need to think about what features make up which part of which layer. So you might want to watch a video to do this, or you might want to just sit through this to help you, but there's 2 features for each layer. So let's first of all look at number 1. So number 1 says there is a liquid layer made up of iron and nickel. And this is talking about the core, and it's actually referring to the outer core. So I'm just going to put in this little box here the OC. So if the outer core is a liquid layer made up of iron and nickel, then what do we think the inner core is like? Well, the inner core is the actual opposite. It's a solid layer made of iron and nickel. What's the next one then? Well, number 3. This is made up of semi-molten rock called magma. Now remember that magma is what we get coming through volcanoes, so it must be quite close to the Earth's surface. So we actually find magma in the mantle. Now remember that when magma escapes and gets onto the Earth's surface, it becomes known as lava. Now, number 4 is the hottest part of the Earth, and it has temperatures of up to 5,005 degrees, which is as hot as the sun. Now remember that heat rises. So if the heat is rising, which part do you think would be the hottest part? Well, yeah, it's the inner core. Number 5 then, solid rock. Well, we already know that the outer core is a liquid layer. We already know that the inner core is a solid layer. We already know that the mantle is semi-molten, which means that there's only one layer we haven't referred to yet, which must be the crust. Question number 6 then, lower down the rock is soft and beginning to melt. This is known as the outer core. Okay then, so which is the thinnest layer? Well, you can see straight away from looking at this diagram that the outer core and the inner core are quite thick, as is the mantle, which suggests that the thinnest layer must be the crust. And then by process of elimination, you will be able to work out that number 8 is talking about the mantle because there's only one other that is referring to that one. So, task number 2. When we look at the crust layer, there are 2 different types of crust that we need to be aware of. The crust can either be a continental, so that is what we find beneath continents, or oceanic, which is what we find beneath the ocean. So the oceanic is beneath the oceans, and the continental is beneath the continents. Now, on your sheet, you will notice that there are a variety of statements that you need to annotate and add to your images. Now, I'm not going to go through them all because some of them are quite straightforward. You might want to remove where it says lithosphere and change that to mantle, so we're keeping the same terminology. So we've got mantle here. So the oceanic crust is obviously forming beneath oceans, and the continental is forming beneath continents. When it asks you which is thicker, well, you're looking at this section here, so it's very clear that the oceanic crust is much thinner than the continental crust. When you're thinking about the density is important because if you had 2 buckets of sand, if one bucket of sand was full of dry sand and then there was one bucket of sand full of wet sand, the wet sand bucket would be much more compact, and as a result it would be denser and heavier. So if we have the weight of the ocean pushing down on this oceanic crust, so the weight of the ocean is pushing down on the oceanic crust, this is going to mean that it's heavier and denser, which is why you can see here that this oceanic crust actually sinks, and we'll look at this in more detail next week. Now, if the oceanic crust is heavier and denser, this means that the continental crust is less dense. So think back to the analogy of the sand and the bucket, the dry sand, which means it's lighter. So as a result, continental crust is more likely to actually push upwards and create things like volcanoes, which is what you can see here. So use this information on the video to help you complete task 2. Task 3 then, we are looking at the different plate boundaries. So the crust of the earth is broken into many pieces called plates. So imagine if you smashed a plate, it would all break up into little pieces, but they would all be able to be jigsawed back together. And this is what happens to the plates. Now, it's important that when we're talking about specific case studies, we need to know what plate boundaries these earthquakes or volcanoes occurred on. So you will notice that on your tasks, you have got labelled A to H, and the numbers are 1 to 8. So you need to use your information of your continents to help annotate these. Now, I'm going to help you with some of them because some of them aren't as clear cut. But let's do a couple together. So here, G, we can see that this plate is very close to Australia, which is here. So the name of this plate boundary is the 3 Indo-Australia. F is right over Africa. And oh look, there's a plate boundary called the African plate. So F is called the African plate. Now the ones that are a little bit more difficult to know is actually D. So D is known as the Nazca plate. And that is probably the one that you would struggle with the most to work out its location. When you think about Eurasia, think about Europe. When you think about the Pacific, you're thinking about the oceans. And then the North American plate and the South American plate, well, they're going to be near the North America and South America continent. So make sure you've labelled your thingies, or you might want to just write down 1A or go through and put the letter next to the number. There's not really a clear-cut way that you need to do this. So task 4 then and task 5 are very similar. You need to describe the distribution of earthquakes, and then for task 5 we're describing the distribution of volcanoes. Now you will notice here all of the little dots on this map are showing us the location of earthquakes. And you'll notice that most of the earthquakes are found along these plate boundaries. So remember that this plate boundary is the Nazca plate boundary. We have the Australian one here, or the Indo-Australian, sorry. We have the Eurasian plate here, and we have the African plate here. So generally, all of these volcanoes are occurring all of these earthquakes are occurring on these plate boundaries. So if we were describing the distribution of them, the first thing you would need to do is talk about the trend. So is there a pattern? Well, there isn't a pattern in relation to where they're found around the world. They're quite random. However, there is a pattern in the respect that they're found on plate boundaries. So earthquakes are found on these plate boundaries. Where's the evidence then? So you might want to refer to some of the plate boundaries from task 3. So the fact that they're found along Indo-Australia, the Nazca plate, the African plate, on the border of the Eurasian plate, and then you might want to talk about the oceans that you find them in. So the majority of earthquakes are occurring within the Pacific Ocean. So you can see here, if I change my colour, there's a lot of earthquakes happening in this region, and look how many are occurring in this region, all part of the Pacific Ocean. So you talk about actual specific places, how many there are roughly, and then for the anomaly, you talk about areas where earthquakes actually don't occur on a plate boundary. So you'll see that there are a few. There are a couple within Australia, and there are also a couple within Africa. So these would be known as our anomalies because they don't follow the general pattern. So using this information and all of the words at the top, have a go at describing the distribution of earthquakes. Now for task 4, you do exactly the same. Now this image is actually a little bit easier because it tells you the names of the plate boundaries. So you might want to use this to double check over your answers for task 3 to make sure that they're correct. So you need to go through and describe the distribution. Now remember that this line here is showing you the location of all the plate boundaries, and the little dots are showing you the location of the volcanoes. So these ones here would be our anomalies. Ones that are found along or near plate boundaries would be the trends. And then for your evidence, you would just make reference to the continents, the oceans, and the plate boundaries. Now, once you have completed tasks 1 to 5, you will notice there is an assessment that you can submit all of your work to. So please make sure that you submit all your work to there. And then in your next lesson on Friday, you will be completing exam questions. So you will only be learning new content on Mondays and Tuesdays, and then on your Friday lesson, you will be consolidating your knowledge by answering timed exam questions. If you have any questions about the work, please send me a message, and please make sure that you also do the retrieval quiz, which is at the start of every lesson. Good luck and well done.